All right, since majority of you guys are finished with this one, what you guys get when you plugged in -3, remember, you are rounding the 3 significant figures, okay? You are rounding the 3 significant figures. When you plug in -3, Elizabeth, what'd you get? What's that point? And when you plug in -2, Katie? Negative what? 3? 2? When you plug in -1, Aiden? Okay. Ian, help him out.
-1, you plug in -0.738.
When I plug in 0, Alex? Oh, wait. Negative. Wait, say it again.
It's -0.657.
You plug in 0? You have to be -0.657? Double check that. It is -0.6, but 60. Because you check out -0.6598, so that 8 will round the 9 up to. When you plugged in 1, over here, Bethany, what you get?
-0.5.
Good. John Paul, what you get when you plug in 2?
-0.570.
0?
6. No, that's a 6. Oh, I can't read my own hand right. That is a 4, yeah.
That's a 4. Yes, and when you plug in 3, Sarah, what you get?
0.69.
Say again. 0.69. Good stuff. So this looks like roughly something of this nature, right? So then you'll be able to describe all of your information. What is the domain here, Justin? What's the domain? Very good. -infinity to infinity, because as x goes to -4, -5, -6, or +4, +5, so on and so forth, it's going to continue to get bigger. What about the range here? What about the range, Tyler?
-infinity to infinity.
Say again.
-infinity to infinity.
-infinity to infinity. Very good. It's going to continue to get bigger and bigger. What about the intercepts? What about the intercepts? Did you guys figure out what the intercept was? Maddie?
The y-intercept is -0.66. So it's 0, -0.660.
To find your y-intercept, you plug in 0 for x, and so you get that corresponding y value. That's your y-intercept. What about your x-intercept? How do you find your x-intercept? Just in general, how would you find any x-intercept? You set it equal to 0, okay? So if I were to set this equal to 0, do a little bit of work here. How would I solve for x? What would I need to do? Divide by 1/2. And what's 0 divided by anything? 0.
What are we finding?
We're finding the x-intercept. What about here? What do I need to do now? Take the 5th power of 0, which is? Because just like if this was a square root, you would square both sides. So since it's the 5th root, you would raise 5 to both sides. Now, what? How do I solve for x? Sarah?
Add 4 and then divide by 3.
Add 4 and then divide by 3. So there is your x-intercept. It's located at 4/3, comma 0. What about my end behavior? Let's see. We'll go right to end behavior first. Vivian, what's happening as x approaches positive infinity? What's happening to my y? It is going towards infinity. And what about as my x's approach negative infinity, Megan, P? It goes to negative infinity. Very good. Last but not least, two things actually. Is it continuous? Yes, and it's continuous on that entire interval. You guys have enough space for this, correct?
Yes.
Good stuff. All right, and then what about increasing or decreasing?
It's,
Did I hear increasing?
Yes.
yes.
Okay. From what to what? And there's all your information. There's all your information. Okay? Questions? Okay. Up to this point, did we do all the examples? Because I cannot remember what we got through on Friday.
Just the,
Well, except for the back ones, the equations, but everything else with the graphs.
yes.
And we filled in all the blanks. Okay, good stuff, okay? So, now you can know everything without even having to worry about graphing it, okay? So make sure of that. Now, you guys had a few problems on your homework,
1 through 3.
1 through 3, right? The graphs. Did you have any issues with those?
Number 3.
Number 3 was an issue.
Type test.
Solving radical equations. So the second part of the goal, okay, which was to be able to solve radical equations. Now, you guys should be able to solve problems like this, correct? How do you get x by itself?
Square.
Square both sides. Okay, good stuff. So in this case, x would equal what? 9. You should also be able to do problems like, you should also be able to do problems like this. By doing what?
Square.
Squaring both sides. So then, what's 16 squared?
256.
256. Okay, and so on and so forth, okay? But we're going to get into the more complex types of problems, okay? Like the ones you see on the back side of your notes, okay? So, but the same key principles occur. Get your radical by itself on one side before you start squaring or doing anything, okay? So in this particular problem, the first thing we need to do is
Get the radical by itself.
by doing what?
And bring the negative 3 to the other side.
By adding.
Yeah.
And now that your radical is by itself, we square both sides. Now be very careful, because when you square the left side, what do you actually have to do? FOIL.
Foil.
I distribute that square with FOIL. So, 2x plus 3 times 2x plus 3,
4x squared.
4x squared. Then what?
Plus 6x.
Plus 6x.
And then another 6x, which gives you the 12. And then plus 9.
So remember to FOIL anytime you have a binomial being squared. Okay? Now from here, how do we solve for x?
Take the 28
You bring everything to the one side.
Bring everything over. Because what is this actually?
Quadratic.
A quadratic. And we just did a unit on solving quadratic equations. So I subtract the 28x over, subtract the 29, and I have a nice quadratic that I can solve. Can I factor this? First thing you look for when you factor is there one?
Yep.
What is it? Can I factor the inside here?
X minus 5 and x equals 5 and
Question.
So you saw that they all have 4 in common, so you divided everything, you took the 4 out. Don't, when you're doing the 4 equals 0, doesn't that become its own x as well? Like 4 can't equal 0 as 4.
Well, you'll have 4 equals 0, which is basically nothing. Now, if it was a 4x equals 0, then that would actually be a solution. But yes, we apply our property. and x equals 5, and x equals -1. Now, when you get your solutions, you just don't circle them and move on to the next problem. What you have to do, you've got to check for extraneous solutions, okay? You've got to check. So to do that, you take your answer of 5 and -1 and plug it into the original equation, okay? And so yes, when I plug in 5 in for x, I get a 10 equals 28 times 5 plus 29 minus 3. Now you don't need your calculator to do this. You can do this without your calculator, okay? 28 times 5.
5 times 8 is 40. Carry the 4. 5.
140.
10. 140.
So 140. 140 plus 29 is,
69.
and you should know what the square root of 169 is. 13. So is 13 minus 3 10?
Yeah.
So 5 works. Plug in -1. 2 times -1 is -2. What is 28 times -1?
Negative 28.
And when I add 29 to that, what do I get? You get a 1. What's the square root of 1? So then they both work. Always check, because no, they won't always work. Okay? The same rule applies. Get that radical by itself, do the opposite, or do the corresponding power to get rid of it. Sometimes they're quadratic, sometimes you won't. The next one. What should I do first?
Add 8, minus 8.
12 minus 8 is?
4. And you gotta cube it. Wait, if you have like a square, does it make the cube like a 1?
Oh, doesn't make 1. This could actually also mean this. Whenever you have a root, you can write it as a rational exponent like how we talked about on Friday. But that's a little ugly to deal with.
Just
But-
flip it over.
How can you get rid of the cube root? Oh, not cube root, but
Cube it.
cube it. So then what's 4 cubed?
64.
See, if 64 equals this. And then how do you get rid of the square?
Oh, no, yeah, you got
And it's 8.
Careful.
8 times 8 is 64.
True. But it's also
8. Oh, plus or minus 8, right?
plus or minus 8.
Oh.
So not just the positive, the negative version as well. Okay, question.
Yeah, I find the new one that
And so then you would end up basically squaring 4 cubed, which is the same thing. Alright? But you do have to still be aware that you have a plus or minus. But yes, you have a plus or minus 8, not just a positive 8, but a -1 as well. So I'm going to have how many solutions here? 2. I'll have 8 minus, not minus, plus 2. Made the same mistake on the key as well. That's why it wasn't working. I was like, what is my issue?
-8.
What's this? So I can have 8 plus 2 or -8 plus 2. So what are my 2 solutions?
10 and -6.
Can you guys check these to see if they both work?
Yes.
So you always check. Now the last one. Okay? This involves a little bit more. Because unlike the other two, what's different about C compared to A and B?
There's 2 radicals.
It has radicals on both sides. So this one's going to take a little bit longer. Now, I know you're probably already a third down at the bottom of the page, okay? So you probably want to write a little bit smaller for my bigger writing individuals. Okay? So, you have a square on both sides. And it's not like you can subtract the square root over and then try to combine square roots and then try to square it and go from there.
Why did you square root everything? I squared everything.
Yes, that's exactly what you want to do. You want to square both sides, okay? Now, when you square both sides, you'll end up getting rid of one square root, okay? The one on the left, when you square root, or when you square the square root of x plus 1, what do you get?
X
X
plus
plus
1.
1.
Plus 1. But on the right side, it does not become 1 plus 2x minus 12. You're going to have to
Foil?
FOIL.
What?
I hate it.
But you guys, not that bad.
Oh my god.
That was like.
Okay? So, FOIL. Your first is going to be what?
Boy.
Your outer is going to be
Oh, square
2x minus 12. Your inner, and then your last. You get 2x minus 12 without the square root. Remember, when you multiply the same thing underneath the square root, it goes away. Okay? So I promise this.
Then what do you do?
Combine like terms. Right now, I can only combine 1 and negative 12 to get what?
-11.
Negative 11. I can't combine these two, because the only way you can add radicals is if you have the same radicand.
Radicand?
Radicand.
What's wrong?
It's the part underneath the radical. So like that 2x minus 12 is called the radicand.
Can? Can.
Like, alright. Radicand. Sorry, radicand.
You can.
And after together. So we basically have, to add these two together, all we do is add the numbers on the outside. So this is a 2 square root 2x minus 12.
Oh yeah.
Then we'll still have that 2x minus 11. And all of that equals x plus 1. Now we just have one radical that we need to give by itself. So what do I do to that 2x?
Subtract 2x.
Subtract it over, so I'll get a negative x. And then what do I do to that negative 11?
Add
To get a positive 12. Now that's gonna make it a little nasty.
How can you square everything?
From here, don't divide by 2, because you're gonna end up basically getting a fraction plus the whole number. Sometimes, depending on the numbers, you might get 2 fractions, and that's something nasty to deal with. Okay? So go ahead and just square everything as is. On the left side, what are you gonna have to do? You're gonna have to FOIL. Negative x times negative x.
X squared.
Negative x times 12. And another negative 12x make a 12 times 12 is. So there's the left side. The right side. This you can actually square the outside and square the inside. So this becomes 4 times 2x minus 12. The reason why we don't have to FOIL this is because it's not like we're saying 2 plus the square root of 2x minus 12. They're just being multiplied together, so we square both pieces.
So it's 8x
You want to
minus
FOIL?
48.
And now we just have a quadratic that we solve. I'll give you guys a second to solve it out. This is factorable, but if the numbers are too big for you, you could always use quadratic formula. Either one, you can still get the same answer here. However, there are 2 numbers that multiply to give you 192 that add together to give you a negative 32, and they are negative 24 and negative 8. So when I use my zero product property and set both of them equal to 0, I end up with the solutions x equals 24 and x equals, but I need to check both of them by plugging it into the original. So when I plug in 24, I have the square root of 25 equals 1 plus 48 minus 12. What's the square root of 25?
5.
And then what's 48 minus 12?
36 divided by the square root is 6.
Whoa.
And then what's 1 plus 6? That does not equal 5, does it? So 24 is not a solution.
Because I had an X. You have to check. And I'm like, oh no.
Let's check 8. 8 times 2 is 16. What's the square root of 9? 3. And what is 16 plus 12?
Minus 12 is
Oh, sorry, 16 minus 12.
4. Square root is 2.
4, square root of 4 is 2. So we have 3 equals 3. And that one does work. So I only have one solution here, and that is 8.
Would you like doorstop? I would love doorstop.
This is the combination of